In this lecture, I'm going to look at two different examples, and we're going to use the completing the square method to solve these polynomials. The first thing you have to do with completing the square is you need to make sure that you get all of your x terms to one side of your equation and all of your constants to the other. So what this means is I am going to take my x term, my negative 8x, and I'm going to move it to the other side, while taking my 7 and moving it to the other side. Okay, so we're going to kind of swap things around. So in this case, we end up with x squared plus an 8x. I'm going to give myself a space because the point of completing the square is making a perfect square on one side of your equation. Now on this other side, I have negative 8 minus 7. So this is going to give me a negative 15. Okay. Now I'm also going to leave myself a space because whatever I have to do to my left side, I also have to do to the right. Once we get your equation kind of set up the way it's supposed to be, we're going to actually do what's called the complete the square step. Now this step I like to do as one single line, and I like to do each step even though it may be a little bit tedious, but essentially what we're doing is we are going to do b divided by 2 and square it. Okay, this is the complete the square step. So in this case, my b term comes from standard form, and the most important thing is that you bring the sign along. So this is going to be plus 8 over 2 and square it. Now I am going to reduce this fraction first. So here we're going to end up with a result squared. And if we reduce the fraction, 8 over 2 reduces to a positive 4. And then we're going to get a result. Well, if we look at 4 squared, this is going to become a positive 16. Now, the reason why I do each of these 4 steps is because, as follows, the 16 here, this ends up being the value added to the left and right side of the equation. Okay, so that's what's important about this 16, is it gets added basically into these blank spaces. Okay. Now this red piece, so this 4 right here, this is actually the perfect square factor. Okay, so this is how this works. We had x squared plus 8x with a space is equal to negative 15 with a space. So this 16 right here is what comes down into these 2 blank spaces as plus 16 and plus 16. Okay. Now that being said, this is now a perfect square. So this gets rewritten as x something squared. And then negative 15 plus 16 is 1. Well, in this case, this positive 4 is what comes all the way down here, and this is a plus 4. Now this is the reason why the sign is so important during this step, is because it dictates the sign of your factor. So now that we know that, what you can see here is that we have actually set up the square root method. So all we have to do at this point is isolate for the x. So we're going to end up with x plus 4 is going to equal plus or minus the square root of 1. So this is x plus 4 equals plus or minus 1. We got to get x by itself, so x is equal to negative 4 plus or minus 1. Now the biggest thing at this point is you still have to do the math. So you can't just leave it as -4 plus or minus 1. You actually need to finish it out. So we are going to end up with x being -4 plus 1. So x is -3. And we're going to have x is my -4 minus 1. So x is -5. Okay. These would be then the two solutions to my problem solved by completing the square. Alright, let's do this one more time just so you can see how it works, especially if we find that we have an x squared term where the coefficient's greater than 1. So again, just like before, we want my x's on one side and all of my coefficients to the other. So I'm going to take this 6 and I'm going to shift it over. So this becomes 3x squared minus a 5x. I'm going to give myself a space, is equal to -9, and I'm going to give a space. Now, once you do this, there is one very important rule, and that rule says that the coefficient of the x squared term must be 1. In this case, it's a 3. So we have to make it 1 by dividing everything by 3. When we do that, we end up with an x squared minus 5/3 x, leave a space, is equal to -3, and leave a space. Now that my x squared term is 1, I can go ahead and complete the square using the information I have. Now, because this is a fraction, I'm going to rewrite this step a little differently, and what happens is this ends up being b times 1/2 squared. Now we know that's exactly the same thing as saying b divided by 2, and the reason why we're doing it this way is because my b term is a fraction. So in this case, I end up getting -5/3 times my 1/2, and we're going to square it. So just like before, we're going to have a term squared, and then we're going to have a result. So in this case, my sign is negative. Multiplying my fractions goes straight across the top, straight across the bottom. So this is 5/6. When I square that, you square both terms, so this becomes a positive 25/36. Now, just like before, remember, this last term is what goes into my two blank spots. So this is going to become x squared minus 5/3 x plus 25/36 is equal to -3 plus 25/36. Now, before we move on, the first thing that we have to do is we need to combine. And we have to combine using our like terms. So the first thing is we need to remember that all whole numbers can essentially be written over 1. So here we have to combine this by saying that we have -108/36 plus a 25/36.
Oh, that would be great.
So when we combine that, we're going to end up with -83/36. That is what this is going to end up being. Okay. Now my perfect square is going to come from this piece in here. So again, if you remember, we would have x squared is equal to the -83/36. So in this case, this -5/6 is what's going to come straight down here. So -5/6 goes inside. Once you have everything set up, it's just like before. We would go ahead and use that square root method. So in this case, we would end up with x minus my 5 over 6 is equal to plus or minus the square root of negative 83 over 36. A couple things have to happen here. First, this negative is going to pull out as a complex. So in this case, we end up with my x minus 5 over 6 gives you plus or minus I square root of 83 over 36. Now with that, in order to take care of this radical here, we have to use your radical division rule, which says you have to separate your radicals, so the square root of 83 over the square root of 36, before you can evaluate. 83 is not going to reduce, so this is going to become the square root of 83 over 6. Once we do that, we have x minus 5 over 6 is equal to plus or minus the square root of 83 over 6i. We need to move that 5 6 over, so x is going to be equal to 5 over 6 plus or minus the square root of 83 over 6i. Now in this case, there's nothing more to do because of the complex. That being said, a big hint I can give you when working with these fractions is whatever fraction you get as part of your factored term, look at its denominator. Because over on the other side, when you reduce down, those denominators should match. So if you look at the bottom, both of my denominators are a 6. That is one indication to me that I have most likely reduced as far as I can go. So there are two examples, very different examples, one with whole numbers and one with fractions, both of which are solved by using the completing the square method. Okay, so if you have any questions with completing the square, please let me know. Completing the square can be one of the more complicated solving methods that we have, so be very careful, take your time, and during this complete the square step here, make sure that you do each piece individually, as it is these last two pieces that is what you need in order to solve your problem. Otherwise, I do hope you enjoyed this video, and I'll see you next time.